mathematics, factorization or factorization, seeking the spelling differences, or factoring consists of writing a number or another mathematical object as a product of several factors. Writing a number or another mathematical object as a product of several factors, usually smaller or simpler objects of the same kind. Usually smaller or simpler objects of the same kind. For example, 25 is a factorization of the integer 15, and x minus 2, x plus 2 is a factorization of the polynomial x square minus 4. Open bracket x minus 2 close bracket times x minus open bracket x plus 2 close bracket is a factorization of the polynomial x square minus 4. The polynomial x square plus cx plus d, where a plus b equals c and ab equals d, can be factorized into, in parentheses, x plus a, in parentheses, x plus b. Factorization is usually considered meaningful within number systems processing division, such as the real or complex numbers, since any x can be trivially written as xy, in parentheses, time y 1 over y, in parentheses, 1 over y is not 0. However, a meaningful factorization for a rational number or a rational function can be obtained by writing it in lowest terms and separately factoring its numerator and denominator. Factorization was first considered by ancient Greek mathematicians. In the case of integers, they proved the fundamental theorem of arithmetic, which asserts that every positive integer may be factored into a product of prime numbers which cannot be further factored into integers greater than 1. Moreover, this factorization is unique up to the order of the factors. Although integer factorization is a sort of inverse to multiplication, it is much more difficult algorithmically in a fact which is exploited in the RSA crypto system to implement public key cryptography. Polynomial factorization has also been studied for centuries in elementary algebra. Polynomial factorization has also been studied for centuries in elementary algebra. Factoring a polynomial reduces the problem of finding its roots to finding the roots of the factors. Polynomials with coefficients in the integers or in a field possesses the unique factorization property, a version of the fundamental theorem of arithmetic with prime numbers replaced by irreducible polynomials, in particular a univariate polynomial with complex coefficients admits a unique to ordinary factorization into linear polynomials. This is a version of the fundamental theorem of algebra. In this case, the factorization can be done with root finding algorithms. The case of polynomials with integer coefficients is fundamental for computer algebra. There are efficient computer algorithms for computing complete factorizations within the ring of polynomials with rational number coefficients. See factorization of polynomials. A commutative ring possessing the unique factorization property is called a unique factorization domain. There are number systems such as certain rings of algebraic integers which are not unique factorization domain. However, rings of algebraic integers satisfy the weaker property of Dedekind domains. Ideals factor uniquely into prime ideals. Factorization may also refer to more general decompositions of a mathematical object into the product of smaller or simpler smaller, simpler objects. For example, every function may be factored into the composition of a surjective function with an injective function. Matrices possesses many kinds of matrix factorizations. For example, every matrix has a unique LUP factorization as a product of a lower triangular matrix L with all diagonal entries equal to 1, and upper triangular matrix U, and a permutation matrix P. This is a matrix formulation of Gaussian elimination. Polynomial factorization. In mathematics and computer algebra, factorization of polynomials or polynomial factorization expresses polynomial with coefficients in a given field or in the integers as the product of irreducible factors with coefficients in the same domain. Polynomial factorization is one of the fundamental components of computer algebra systems. The first polynomial factorization algorithm was published by Theodor von Schubert in 1793. Leopold Ronecker rediscovered Schubert's algorithm in 1882 and extended it to multivariate polynomials, multivariate polynomials and coefficients, multivariate polynomials and coefficients, multivariate polynomials and coefficients, polynomials, coefficients, polynomials and coefficients in algebraic extension. But most of the knowledge on this topic is not older than circa 1961. The first computer algebra systems, the long-known finite step algorithm, were first put onto computers. They turned out to be highly inefficient. The fact that almost any uni or multivariate polynomial of degree up to 100 and with coefficients of a moderate size up to 100 bits can be factored by modern algorithms in a few minutes of computer time indicates how successfully this problem has been attacked during the past 15 years. Eric Kaltofen, 1982. Nowadays, modern algorithms and computers can quickly factor univariate polynomials of degree more than 1000 having coefficients with thousands of digits. 1000 more than 1000 having coefficients with thousands of digits, having coefficients with thousands of digits, coefficients with thousands of digits, coefficients with thousands of digits. 1000 more than polynomials, univariate polynomials of degree. Quickly factor univariate polynomials of degree more than 1000 having coefficients with thousands of digits.